Hello everyone, welcome back to my channel. In today's video, let's learn about generic process model. So, let's start the video. First, let us see what is a generic process model. Generic process model is a definitive description of processes. Generic processes are designed to run outside a normal component or an application processor. These processes are not specific to any particular component and can be used in any number of applications. The software process is a collection of various activities. These activities include communication, planning, modeling, construction, and deployment. Each of these activities includes a set of engineering actions, and each action defines a set of tasks that incorporate work products, project milestones, SQA, also known as software quality assurance points. Generic process model includes the below five framework activities that are communication, planning, modeling, construction, and deployment. Let's see the first framework. Communication. This is the first step in the software development process, which starts with the communication between the customer and the developer. Next, planning. This step consists of a complete estimation of the project, scheduling for development of the project, and tracking. Modeling. This step consists of complete requirement analysis and project design like algorithm, flowchart, etc. Next is construction. This step consists of code generation and its testing. Coding will implement the design details using appropriate programming languages. The last framework is deployment. This step consists of delivering the final product to the customer and take feedback. If there are any suggestions or addition of other capabilities, then this change is required for improvement in software quality. There are types of process models, process flows. There are four types. Let's see the first one, linear process flow. It executes each activity listed in the below sequence form, which is first is communication, next is planning, the next is modeling, and then construction, and then deployment. It is in a linear form, that's why it is called as a linear process flow. The next is iterative process flow. This flow repeats one or more activities that are listed above before starting the next activity. That is, as you can see, the first is communication, then planning, and then again after planning, it goes back to communication, and then it goes to planning, and then modeling, and then it repeats modeling again if necessary. And then it goes to construction, and then again from construction, it goes back to communication, and then lastly, it reaches to the deployment. It's an iterative process. So, as it says here, the flow repeats one or more activities. It can be any activity according to their choice. The next is evolutionary process flow. This flow carries out the activities listed above in a circular manner. Each circle leads to the more complete version of the software. So first, it'll start with communication, planning, modeling, construction, deployment, and it'll release. And if it requires, you know, upgradation, and then again it goes back to communication, planning, modeling, construction, deployment. It goes through all those stages again, causing it to move in a circular manner. So each circle will lead to a more complete version of the software. The last is parallel process flow. This flow executes the activities listed above in parallel with each other. That is, modeling for one aspect of the software in parallel to the another aspect of the software. For example, here, if you see in this image, communication and planning are happening, and then as they are happening, modeling is also happening. And then after communication, planning, and modeling are done, it goes to construction and deployment. So here it shows that a few activities can be done in parallel with each other. And now, that's all for today's video. Thank you everyone for watching. Please like, share, and subscribe. And stay tuned for the next video.